Hi everyone, and welcome to a new episode of the Allplane Podcast, where we talk with the movers and shakers redefining the future of commercial aviation. And before we dive into today's conversation, I would like to remind you that all previous episodes of this podcast, along with many other interesting stories about innovation and sustainability in aviation, are available on the Allplane website at Allplane.tv, Allplane.tv. And I would also like to invite you to subscribe to our newsletter, which focuses on sustainability in the aviation industry. You can find the subscription link right on our website. And now it's time for today's episode. Today we're going back into electric aviation, and we are going to look in particular at one of its main bottlenecks, batteries. This is a topic we have touched upon in the past on this podcast. Batteries have actually always proved to be a very popular subject on this pod. I guess this is because so much depends on the continued development of this technology to be able to have a viable electric aviation industry. And our guest today is at the front lines, so to speak, of battery development. Gerard Torres is a Chief Commercial Officer at Bolt, a company specializing in advanced battery development. Bolt is a relatively young company which was founded near Barcelona some 6 years ago, and it has already developed a global presence. Bolt designs and develops battery systems on demand, and it has also a range of off-the-shelf products for both the automotive and the aerospace industries. Bolt has also been partnering with quite a few major names in the aerospace, defense, and automotive industries. In today's episode, we're going to talk about this fascinating tale of entrepreneurship, but also about the state of the battery industry as of the first quarter of 2026. We're going to discuss which are some of the most promising chemistries being tested right now and the prospects for technological advances in this field. So at this point, I think it's best if I shut up and we listen to what Gerard has to say about the state of the battery industry. So without further ado, let me welcome him to the podcast. Hello, Gerard. How are you?
Hi, Mikel. I'm very well, thank you. How are you today?
Great to see you again. We almost coincided a few days ago at WDS in Saudi, but finally change of plans. It didn't happen. Yeah, but I've got a chance to visit your factory last year, I think, which is very interesting. You are the ideal guest to talk about the state of batteries for aviation, because you guys at Bolt have been doing quite a few interesting projects. Not all of them in aviation, but aviation is one of your areas. I think it will be an interesting conversation to get up to date with this. First of all, I would like to ask you to introduce briefly, basically who you are and what you do at Bolt, and then we can maybe talk a little bit about the company and all these projects that you are working on.
With pleasure, Mikel. So my name is Gerard Torres. I am currently serving as the Chief Commercial Officer at Bolt. A bit about my background. I am originally from Barcelona, Spain. But from the early days of my career, I started working in Formula One racing as an engineer. I spent most of the time with Mercedes F1 in Brackley in the UK. And that was a very interesting time because not only was I working for a great brand, but also because we managed to get a very, very good track record and very successful years winning multiple championships. So that is my background, very focused in motorsports, for many years. Also worked for Toyota in Cologne, Germany, before joining Bolt. Engineer at heart, but also very much focused on business today, as you well know.
Mm-hmm. Yeah, well, maybe that's the right moment to introduce Bolt. I think it's a very, very interesting story because it's a very, I would say, textbook case of the startup that was started, I think, not in a garage, like it's common in the US, but in Europe, people tend to live more like in apartments. But I think it was started in the founder's apartment during the pandemic. So it's a pretty young company, and in these last 5-6 years, it's grown significantly. You are now based, you have a kind of like a large industrial facility in a town near Barcelona, but you operate on a global scale. And as you mentioned, you come from an automotive background. Bolt is very active in automotive, in batteries for land systems, but you have also got into the field of aerospace and electric aerospace. So that's, I think, where I would like to focus our conversation, but maybe we can talk a little bit about this story of Bolt and how you got there.
Absolutely. So, as you say, I think if we were an American company and we were in Silicon Valley, we would say that we're a guide startup, as you were well mentioning. And I think we are a successful case study or story for a bootstrapped company, as it's commonly known in the young business world, emerging companies world. The company started in 2019 by my colleague Bernard Carreras. He's also a former F1 engineer. And initially, the company started providing engineering services to Formula One teams, a variety of F1 teams, in the realm of engineering design, composites, mechanical engineering, simulation. But from the very beginning, there was a vision laid out to become a manufacturer of high voltage battery systems for niche applications. Where does it come from? Basically, Bernat, he used to work at Honda F1, so the power unit supplier, doing the battery, the high voltage battery, the ERS. And with that, basically, with that vision, with that roadmap, we've been working on a variety of very interesting projects from that moment onwards. So yeah, the company started in 2019 through to today, 2026. We are around 140 employees. We've got a global footprint. Our HQ is here near Barcelona, Spain. We've got an office in Oxfordshire in the UK. And we have just opened an office in Michigan in the US as well, where we have really, aggressive plans, so to speak, for the growth of our business. That I'll be very pleased to discuss those, today with you. And what is it that we do? So on the one side, we've got a niche engineering services division that we refer internally as applied engineering. Here, what we do is we work on, very specific vehicle design and engineering and integration programs in motorsports, but also defense and aviation. And then we've got the technology division where we develop high voltage and low voltage battery systems for mission critical applications, we like to say, across a realm of applications, including defense, motorsports, aviation, and marine, amongst other. There's a bit of oil and gas as well, but everything that we do, there's a strong component of criticality in the application somehow. And that's where we feel really, really comfortable. And that's where our engineering capability and our product technological knowledge really comes into play. And it has a very strong fit with our customer base, and it's working really well so far.
Mm-hmm. So you mentioned on your website that you do this end-to-end development of batteries, and then you also have off-the-shelf products. So does it mean that if I'm, let's say, eVTOL developer, let's say, I can come to you and ask you to develop a battery for me according to certain specifications, and you would develop that from scratch? Is that right?
That's precisely correct. Yes. So I think one of the decisions that made this company successful to this day was the approach that we have had. So we've tried to be as flexible as possible with our engagement with our customers. And when it comes to electrification and batteries specifically, normally companies they do not want to spend millions of dollars in energy in development for something that what all they want to do now is not necessarily going to production, but they want to test something either on the bench, on a dyno, or on a few aircraft or vehicle prototypes. So here we've had a product approach where we have developed our own systems. We've got 3 systems at the moment: Volt HP, Volt Air, and Volt HD at different voltage ranges, different cell chemistries.
Those are the off-the-shelf solutions that you have.
These are the off-the-shelf solutions, and again, we fully own the IP, and these are products that have a price, they have a lead time, and they come with an operations manual, and there's a CAN DVC file so that you can integrate it with your control system with your vehicle. And it's meant to be really easy, to get these systems integrated into the vehicle. Systems actually are very complex to develop and to come by, but we try to make it very, very simple and easy to the customer. And then on the other side, we can also either evolve that technology and adapt it to the needs of a specific application, specific customer, or we can create something completely bespoke, completely, from a clean sheet of requirements with different thermal management characteristics, with different cell chemistries, you name it. We've got the right engineering talent here to develop something very, very complex and from scratch.
Yeah, I wanted to ask you about the chemistry. Do you guys have let's say, a favorite chemistry, or you specialize in a specific one? Or as you said now, you can actually work with different approaches.
So we're not married to a specific cell supplier or a specific chemistry because each application will require, different properties and different characteristics from the battery and ultimately from the cell. But everything we do is, of course, lithium ion. We've got some batteries that are using LFP for some applications, but what we're seeing more and more in the niches where we're working and serving our technologies to, these tend to have high nickel content. We are favoring cylindrical cells, but
Cylindrical, huh?
we're mostly working on cylindrical, some pouch in some cases, and very small amount of manufacturing goes into making prismatic cells, battery systems.
Uh-huh. But do you make the cell? You have you don't make the cells. You integrate them in the pack. Is that right?
That's right. We are integrators. Yes, we
Mm-hmm.
don't manufacture the battery cell the cells. We integrate it
Mm-hmm.
into battery packs. So what we're doing is we're taking all the engineering discipline and the F1 engineering modes, and we're taking that know-how and that way of engineering products into batteries, right? So what we end up getting are really high performing battery systems, low weight, really high power, high energy density, and perfect for mission critical applications.
Let's look at some numbers. What sort of energy densities are we talking about? And I'm thinking here about the products that are specifically for aerospace.
Yeah, we've got a product, a high voltage product that's called Bolt Air, where we have achieved gravimetric energy efficiencies of 285 watt hour per kilogram.
Mm-hmm.
But we've got other projects where we are targeting higher energy density than that. So we're saying 300 plus
Are we talking at cell level or at pack level?
at the pack level, at the high voltage pack level, because also what we're seeing in some cases is, we're getting more and more programs for drones,
Mm-hmm.
batteries for drones, and those tend to be a bit simpler
Mm-hmm.
and easier to package, and you get much higher energy densities in those cases. But those applications for aviation that require a large amount of, safety features on
Mm-hmm.
the battery system that adds mass. So getting close to 300 watt hour per kilo is really challenging, and that's what we're seeing.
Okay. So we're talking to recap, 285 to 350.
Yeah, it's over 300 watt hour per kilo. That's what
Okay.
yeah.
Okay. And from my understanding, your work has been mostly on drones, unmanned systems. Is that right?
Is that for aerospace?
Yeah, for aerospace. Yeah.
Specifically for aerospace, we've had a variety of programs. I think both organically and naturally started getting into this sector.
Mm-hmm.
With a company that no longer exists, but it was a lithium metal cell manufacturer out of California called Hubert.
Yes, actually, the founder has been a guest here in the podcast. Richard Wang has been actually a couple of times. Richard Wang was here in the podcast, and yeah, he left the company after it got acquired by Northvolt, which in turn Northvolt got in trouble as well. So yeah, it's an old friend of this podcast. I think he's now working on other ventures also in the battery space. So I should catch up with him.
Absolutely. So we started working on some projects with them. Lithium metal chemistries are very interesting from a performance perspective. They offer really good gravimetric energy densities at cell level, of course, but also they come associated with some challenges when it comes to safety. And what they found in Bolt were the right company that could integrate those cells into high voltage systems and demonstrate that the technologies were, able to be integrated into a pack that would be safe and that would go through, DO 311A TR testing specifically, which is extremely stringent, extremely demanding for, the sector, but specifically for these type of chemistries that can be unstable or that could have safety challenges in some instances. And so that's one of the relevant projects that I can speak about. And we integrated these cells using lots of carbon fiber and composites, managing really high temperatures of lithium ejecta coming out of the cells when entering the thermal runaway. And I think what they got out of it was basically this roadmap to get this product into certification and into production. So basically, that's just to give you a taste of the type of projects that we work on. In terms of the type of aircraft, the batteries that we work on range from, eVTOL, fixed wing, hybrids. So there's really, and then some smaller, airplanes like drones and things like that. But that's just to give an indication of the type of applications where we are applying our technology to.
That would be the Bolt Air system.
Bolt Air is our off the shelf that's been used by, a lot of customers in these applications, but then in many occasions, customers come to us and they want to integrate a specific chemistry into specific space claim, packaged in a specific way, and there are bespoke developments done there.
How do you see the landscape in electric aviation, and particularly when it comes to battery development? I mean, of course, that's the cornerstone of the future development of the electric aviation space. There seems to be a bit of a bottleneck there around the 300 watt-hour per kilogram energy density. There were some Chinese battery developers that talk about going well beyond that. I don't know if that remains a theoretical development or that's something that you see happening in the near future. What can we expect in the next, let's say, 2-3 years in the battery space?
I think a good way to explain it is to think about the product development S-curve. For someone listening, if you Google basically product development S-curve, it's basically like an S-shaped curve drawn horizontally. And that what gives you is how does a technology evolve over time? How does it improve over time? And what we're seeing is that in terms of the batteries, there have been different types of chemistries that have gone through, these investments put in to improve, develop technology and improve it. But ultimately they plateau, it gets to a point where the improvement flattens a little bit. And I think we've seen that in the past with a number of chemistries. We may be seeing it with, silicon anode technologies potentially in the very near future. We may be seeing that. Where I think definitely the industry is not getting the energy density that it requires in order to operate with a business case that can be sustained and that you can compare it with traditional aviation. What I'm seeing is that, solid state cell technologies are coming in, and these will have much longer duration in terms of its development. They will be evolving really quickly as well. We're getting already access to some of this technology at Bolt at the moment. These, I think, for aviation are specifically interesting for a number of reasons. One is, of course, the energy density, can be really high.
If I can stop you 1 second here, for those of us that are not experts, what is a solid state battery? Can you summarize in just a few words what's new with this type of battery?
Yeah, so basically a cell is made of an anode, a cathode, and an electrolyte. And there are components of these that sometimes they have a liquid electrolyte and liquid components. And in this case, basically, these are cells that have solid elements. And this is very innovative technology, things that have been done at lab level, at research level for many, many years. And, a lot of people have been talking about this for a lot of years, but no one could ever see the results of this technology or be able to access this technology. Also because there's been a lot of startups, that have been arising, but very quickly large companies have been acquiring the startups, which basically guarantees their exclusive access to the technology, which makes it really hard for other industry players to access at the same time. But it's becoming more accessible, it's becoming very real. And what we're seeing is basically that these chemistries offer really good energy densities. We are already getting, samples at this stage, and yeah, very good energy density, really good safety parameters. To give you an indication, a regular lithium-ion cell may fail, above 150 degrees C, may go into thermal runaway, whereas a solid state battery cell, it may fail over 380, 400 degrees C. So this makes the thermal management challenge, a lot less challenging. On the other side, there are still a few things that need to be improved, like the cycle life is still fairly low for this technology. And
Sorry, what do you mean? What do you mean by that?
So the cycle life, it's basically how many times you can cycle the cell. So a cycle being charging it and discharging it, without losing, the performance that you need from it, right? And it can be like 90% depth of discharge, 80% depth of discharge. Like there's different ways of measuring it depending on the application. But that is ultimately the cycle life. So how many times you can cycle it without losing the core performance characteristics of the cell. What we're seeing is this technology has still relatively low cycle life comparing to other chemistries. So, aviation, it's a very specific industry when it comes to the application of batteries to it, because the regulatory aspect is very stringent, and it must be that way, of course. Safety is paramount, but ultimately there needs to be a business case for the technology in the industry. And the fact that, some aspects of it are not where they need to be, makes it hard. That is not to say that there are some niche applications where the technology could be applied successfully and there is a business case, right? I do believe strongly that the technology has a place to be already today. But yeah, there are, of course, challenges.
For solid state at the moment, what would be the sort of energy density range we're talking about?
For a cell, at cell level, we would be, depending on the type of cell, but starting from 350 watt-hour per kilo and, all the way up to 500. That's what you could find today.
Okay. And a pack level, I guess, a bit less, right?
Yeah, it's a bit less. Yeah, yes.
Pack is always a bit less because of all the extra, let's say, systems that need to go into it, right? To manage
exactly.
the thermal.
Exactly.
Yeah.
Exactly. Yeah.
So do you dare to forecast the sort of energy densities we could be having in, let's say, the next 3-5 years, considering how things are going? Would you dare to make this sort of prospective exercise?
Probably not. No, it's a very difficult question. I think in less than 5 years, for, again, very specifically referring to high voltage battery systems for aviation, so not referring to like drones that are single use. Basically high voltage battery systems that have to go through DO311A, DO160G, etc. I think we should be getting close to 350 watt-hour per kilo.
Okay.
Fairly soon. So that is within the next, 5 years or so.
Okay. Is there a potential physical limit of how, with current technology, of how dense can this go?
Well, I think ultimately it's the limit is with the chemistry, right? So what is, and it's electrochemistry that goes into it, and I'm probably not the expert at this field to really tell you where the limit is. But ultimately, the performance comes from the cell. There's so much that a chemistry can achieve, and there's a lot of investment again going into these chemistries and also into solid state. So it's going to get to a point that bang for buck, it's not give you that much incremental improvement in the performance. It's going to flatten at some point. I don't think we are anywhere near seeing a plateau on solid state, for instance, as we are seeing with others. So yeah, that would be my answer. I know it's not a very specific answer, but probably not the right person to answer it.
I guess there's possibly no answer. I mean, we're trying to peek into the future in a field that it's in constant development. What we could possibly say is that Bolt is going to be on top of these developments as they happen. What sort of projects or milestones you have ahead?
Yeah, no, that's a good one. So I think for us, the United States and North America in general is a strategic market. We're getting a lot of business out of that region. So we're putting a lot of focus in the States. I am personally traveling over there pretty much on a monthly basis. Over there, we've got amazing customers and really good partnerships. So we currently have an office in the US, in Michigan, and we are currently deploying the investments to manufacture from the States to serve our American customers. So that would see both not only manufacturing product from Barcelona, Spain, but also from the United States very, very soon, probably as soon as early 2027. And in terms of the sectors that are very important to us, I think aviation is definitely a very important sector to us that requires long-term thinking when it comes to cash burn, patience, the products that you have to develop, the relationships that you have to develop. And what we're doing at the moment, where we're seeing strong demand, is in of course motorsports. That's our bread and butter. That's who we are. Allows us to be always at the forefront of the technology and the performance and developing extremely quickly. How these technologies look, but also very importantly, defense. So we're seeing a lot of business coming from the defense sector, from Europe and from North America. We already have very strong partnerships with General Dynamics, for instance. And I think what's important here to mention is that everything is going hybrid for a number of reasons. Not only because of the fuel efficiency that you can significantly improve by adding hybridization and batteries to propulsion systems, but also there's a lot of new systems that are being added into vehicles at the moment to improve the capability of the vehicles. And there's new weapon systems and new functionalities that are being added that require a lot of power and a lot of energy. And more what we're seeing across all applications with the maturity and adoption of new technologies is that everything requires a diversity of sources of energy and power. And here's where batteries basically play a very important role. And I think also what's important is these people need batteries today, right? Don't need batteries in 5 or 10 years' time. They need batteries today, and they need batteries that are ruggedized, that have demonstrated that they work, are reliable, and that deliver really good performance figures. And that's where again we come in. So these are the sectors where we're seeing strong growth. And I think most importantly about why us specifically is that everything starts with our roots from motorsports, where innovation, where development cycles are extremely fast, and you have to be extremely efficient at developing and getting the product to work. I always say in the world of Formula One specifically, every year the challenge is the same. You have to deliver a new car that needs to be fast, needs to be reliable, needs to be drivable, but also needs to be at a specific place in the world at a specific time of the year. And that defines really well what we do. And that's the mindset that we're applying to every single sector that we're working in.
Very good. So people that wish to learn more about Volt, the batteries that you're integrating, your projects, what would be the best resource?
So I think for those that are interested about Volt, of course, I would invite them to visit our website, which is volttechnology.com. You're going to find a lot of information there about what we do, our products and our customers and, our team. And of course, if, I'm a person that is very approachable, always happy to, talk to new people and meet new people. So I'm on LinkedIn and very open to have, people messaging me and chatting to new people. So yeah, happy to meet new people.
Perfect. Well, thank you so much, Gerard, for this very insightful talk about the state of batteries, which is a topic always of interest in aerospace because of so much depends on it. So just left for me to wish you all the best with all these new projects, with this very promising US expansion, and hopefully we'll coincide soon at some industry event. Thank you so much.
Absolutely.
Yeah.
Thank you, Miguel. Speak soon.
If you like this podcast, you can support us by giving it a great rating on Apple, Spotify, or whichever platform you get it from. And remember, you can, of course, subscribe to it. And you can also get regular updates through the Allplane website. That's Allplane.tv. We have a newsletter where we cover the aviation industry every week with a special focus on innovation and sustainability. So give it a go. Thank you and goodbye.